Okay, today we're going to learn about scientific notation. So we're going to start with a problem, a puzzle, and let's say that we are trying to, let's say grow a plant, right? So we start here, we're going to have one seed, and then in the next box we're going to double it, we're going to plant 2, and then 4, 8, 16, 32, 64, 128, 128, 256, right, so on and so forth. So the goal is to figure out how much is here, right? How much is at the end. So if we look here, right, we have, let's say this is day 0. This is what we start with. 1, 2, 3, 4, 5, 6, 7. And right, we're trying to get all the way up. There's 64 squares that we started on 0, so there's 63 days. And if we notice, there's a pattern, right? We're doubling it, so we actually have 2 to the n, where n equals days. So you can try and figure this out. You could pause it, or we could look on the calculator. So we have, change the exposure. So we have 2 to the power of 63. We have this huge number, right? We have a 9.22, and then, right, so we like to round to 3 decimal places, but that doesn't make sense because why do we only have 9 grains of rice, right, when we're already at day 63? So what you want to do when you look at this calculator is actually see this whole thing, right? So we have 9.223372037 e to the 18th. So what does that e mean right there? This is in scientific notation, the calculator. So e means times 10 to the power of. Right, so times 10 to the power of, right? Like in the computer, you could use the caret symbol for power. So we like to round to 3 decimal places, so let's write this as 9.223 times 10 to the power of 18. Right, so that's how much rice we're going to have on that 63rd day. And let's see how big that number is, right? So we have, we're going to move the decimal point over to the right 18 places. 9, 2, 2, 3. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18. This is a lot. Right? So let's write that with our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? So this is a huge number, right? This would be thousands, millions, billions, trillions. So it's even beyond a trillion. So this is like a ton of rice, right? So that is the whole point of scientific notation. It helps us write numbers that are really small or really big in an easy manner, right? So let's make a note here. Scientific notation is a way to write numbers that are really big or really small in a simpler way. All right, let's look at some examples. So write each number in standard notation, so that's normal, right? 3 times 10 to the negative 3, and, sorry, that should be positive 3. So 3 times 10 to the 3, and 7 times 10 to the negative 2. Okay, so if we look at this, right, we can write this as 1,000. So this is 3,000. right? What we could also do is we could take the 3 and we can move the decimal 1, 2, 3, right? So when it's positive power moves to the right, right? Which makes sense because that's like, you know, our x-axis. And then we have 7 times 10 to the negative 2. So that's the same thing as 7 times 1 over 10 squares using our exponent laws. 1 over, and then we get 7 over 100, which can also be written as 0.07. Right, and that makes sense because we're going to move it 2 to the negative 1, 2. So decimal points there, same thing. Okay, now we're going to write each number in scientific notation. So we take our decimal point, we're doing 1, 2, 3. So we have 3.51. Remember, our number always has to be less than 10. So we can't write 35.1. We want 3.51 times 10. And we know that it's a small number, so this is going to be a negative. So 1, 2, 3, negative 3. And then here we have 6.71. 1, 2, 3, 4, 5, 6 times 10 to the 6. And if you're ever not sure, you can always just check on your calculator, right? So we have 6.71 times 10 to the power of 6, and we see that that matches. All right, let's look at the back. So that's weird. Let's look at some examples that are weird. 45.68 times 10 to the 5th, and 24.7 times 10 to the negative 6. Okay, so like I said, when we're doing scientific notation, the number that's in front of the times 10 needs to be less than 10. It needs to be like a number and then a decimal right after. So the number in scientific notation needs to be less than 10, right? So instead of 45.68, we're going to need 4.568 times 10 to the 6th. So sometimes it gets confusing which direction you go, but you just want to think like we moved it over 1, so we need to add 1 at the exponent. You can also use your calculator to check. And then we have 2.47, right? We moved the decimal, so we moved it again to the left. So we subtracted a degree of 10, so we need to make this, we need to add it, negative 5, right? This one we went from 5 to 6, this one we went from negative 6 to negative 5. And again, you can always use your calculator. So like here, 24.7 times 10 to the negative 6. It actually gave it to us already in scientific notation, right? 2.47 e to the negative 5th. Okay, so let's use our exponent laws, right? Bringing it back. We're going to write each in scientific notation. So this is going to be our product rule. This is going to be our power rule. And this is going to be our quotient rule. Okay, so what we want to do is we want to multiply the numbers together, and then we're going to add the exponents. So we have 4.9 times 2.8 is 13.72 times 10. Negative 3 plus 2 is negative 1. But remember, we need this to be 1.372, so we moved it over, we need to add 1 times 10 to the 0, but that's just 1. So we actually just have 1.372. So we could do it like this, but we could also just do it in our calculator. So we have 4.9 times 10 to the power of negative 3 times 2.8 times 10. And we can do the caret right here to do the power, or we could just directly go to squared, because squared is so common that it has its own button. And it tells us right away, 1.372. All right, let's do this one. 3.76 times 8. 30.08, and then we need to add the exponents because, right, remember our GEMDAS rule? When we have multiplying exponents, we add them. So 10 to the 4th, but we need to move this over 3.008 times 10 to the 5th. And let's do it in our calculator. 3.72 times 10 squared, close parentheses, 8 times 10 squared, and we get, so this one isn't given to us in scientific notation, so we have to move it over, right? 1, 2, 3, 4, 5. Okay, let's do power rule. So remember, in our GEMDAS, right, if we have an exponent, we're multiplying. So we need 3.7 squared times 10 to the negative 6th squared. So we have 3.7 squared, 13.69 times 10 to the negative 12th. We need to move this over, 1.369 times 10 to the negative 11th. All right, so I'm going to show you in the calculator how to do a shortcut. So we have 3.7. Instead of writing times 10 to the negative, you can just write the e that you see in the calculator. So it's going to be second comma. So for the e in the calculator, second comma, right? So 3.7 e negative 6 to the power of 2. And then it does it for me. 1.369 e negative 11. All right, let's just do this one in the calculator. 7.8 e5 to the power of 3. 4.74, let's always round to the 3 decimals, right? Times 10 to the 17th. All right, and now we have quotient rule. So remember when we're doing quotient rule with GEMDAS, right, we're trying to divide, so we subtract. So first we do 12 over 4 times 10 to the 3 minus 5, right? So you have 3 times 10 to the negative 2. That's already in scientific notation, we're done. And then this one, let's use our calculator. 2.25 e to the 2 divided by 2, parentheses, 2 e to the negative 6. And then we get 1, 1, 2, 5, 1, 2, 3, 4, 5 zeros. So we're going to do 1.125, 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8. Awesome, that's it. So nice combination of our exponent rules and getting used to scientific notation. You're definitely going to see this in your science classes. I know chemistry has it when you're doing moles. So it's really good to get familiar with scientific notation and understand what that E symbol is on your calculator.